Hello, this is Keenan Park, and this is YLOC 4th grade worksheet lesson 18. For our first section, we have determining prime and composite numbers, and we're going to write whether the given number is prime or composite. So the way you figure out if a number is prime or composite is first we have to define what is a prime number. A prime number is any integer who has only two factors, and the factors have to be itself, so the number, and 1. So for the first number, number 2, if we look at its factors, we can tell that it has the factors 1 and the factor 2. And then 1 times 2 makes 2. And because there are only two factors, 1 and itself, we know that 2 is prime. And then any number that is not prime is composite. 6 over here has a few factors. It has 1, 2, 3, and 6. And we can write this as factor pairs. So 1 times 6 and 2 times 3 are its factor pairs. Because 1 times 6 is 6 and 2 times 3 is 6. So all 4 of these are factors. And you will notice that there are more than 2 factors. So 6 is not prime, it is composite. 8 is also composite because it's divisible by 2. And if it's divisible by 2, that means it has more factors than just 1 and itself, which is 8. So it's composite. For 11, we can try to divide it. If you try to divide it by 2, it won't work. If you divide it by 3, it won't work. If you divide it by 4, it won't work. And you keep on going. And eventually you'll notice that the only numbers that divide it are going to be 1 and 11, which is itself and 1, which means that it only has 2 factors, and so it's prime. The same goes for 13. 13 is also prime. And you can just tell by trying to divide by numbers. As for 15, 15 is not prime because it's divisible by 3. Its factor pairs are 1 times 15, but also 3 times 5. And so it has more than one pair of factors. So it is composite. 91, I mean, it looks pretty prime. It's hard to divide. But eventually, you'll notice that if you divide by 7, you will get 91 is the same thing as 7 times 13. So that means it is composite because the second factor pair is, of course, 1 times itself, 1 times 91. So it has 2 factor pairs, and so it's composite. The last number we have is 119. And, well, we can keep on trying to divide 119. We can try 3. We can try 7. And if we try 7, you'll notice 119 is equal to 7 times 17, actually. So that means it is composite because it has at least 7 times 17, and all numbers have 1 times itself, so that is more than 2 factors. Now we're going to test if a number is divisible by 2, 3, and 5. So I'm just going to write it as little columns. So we have the 2, the 3, and the 5 column, and we're going to write like this. And so we're just going to put a little check mark if it's divisible by 2. So the quick way to find if a number is divisible by 2 is you look at the last number. If the last number is even, then that means it's divisible by 2. 12 ends with a 2. 2 is even, so that is divisible by 2. For 3, the fast way is to add up all the digits. So 1 plus 2 is 3. And then if you add up the digits and that number is divisible by 3, then the big number is also divisible by 3. So 1 plus 2 is 3, and that's divisible by 3, which will give you, so that means it is divisible. And then for 5, the quick way to check is the last number. Is it 0 or 5? If it's 0 or 5, then it's divisible by 5. Otherwise, it's not. In this case, it ends with 2, so it is not divisible by 5. Moving on to 20, it ends with the 0. That's even, so it's a check mark. If we add up 2 and 0, we will get 2. 2 is not divisible by 3, so that's an X. And then lastly, it ends with a 0, which means it is divisible by 5. Now 16, it ends with a 6, which is even, so it's divisible by 2. 3, 1 plus 6 is 7. 7 is not divisible by 3, so that's an X. And it does not end with 0 or 5, so that's another X. For 24, it ends with a 4, that's even. 2 plus 4 is 6. 6 is divisible by 3, and it does not end with a 0 or 5. For 45, 5 is odd, so it's not divisible by 2. 4 plus 5 is 9. 9 is divisible by 3, so it is divisible by 3. And it ends with a 5, so it is divisible by 5. And then on to the last three. 35 ends with a 5, which is odd, so that's a no. 3 plus 5 is 8. 8 is not divisible by 3, so that's another no. But it ends with a 5, so that is a yes for the divisible by 5. For 66, it ends with a 6. 6 is even, so it's divisible by 2. 6 plus 6 is 12. And then we can do the trick again. So we have 12, and then we do 1 plus 2 is 3, and 3 is divisible, so that's a check. And then it does not end with the 0 or 5, so it's not divisible by 5. And then for 25, it ends with an odd number, so that's a no. For 2, 2 plus 5 is 7. 7 is not divisible by 3, another no. And it ends with 5, so that's a yes. Whew. And now for the word problems. Janica has 11 muffins, and she wants to share with some of her classmates equally. She wants to make sure everyone who gets a muffin has more than one muffin, and that everyone that gets a muffin has an equal number of muffins. And explain why this is impossible. So, unfortunately for Janica, 11 is a prime number. That means the only way it can be split evenly or divided evenly is 1 times 11, which means she can either give one muffin to 11 people, but she wants to make sure everyone gets more than one muffin, so that's not possible. So she can also give 11 muffins to one person, but that wouldn't exactly be sharing. She'd just have them all to herself, anyways. So that's why it's not possible to share 11 muffins equally. And then I described the fast way for 2, 3, and 5 earlier. And for 11, it's a little bit different. So if I have some number like, let's say 14,641, and I wanted to determine if it was divisible by 11, what you do is you get all the odd number, or you get the first digit, 1, you write it down, and then you put a minus, and then a 4, and then the next digit 4, and then a plus, and then a 6, and a minus, and then a 4, and then a plus, and then a 1. So you switch the signs, so minus, plus, minus, plus. And then if you do that, you'll get 1 minus 4 is negative 3, plus 6 is 3, minus 4 is negative 7, plus 1 is negative 6. So this equals negative 6. Wait, did I do that right? Sorry, my bad. 1 minus 4 is negative 3, plus 6 is 3, minus 4 is negative 1, plus 1 is 0. And so since it's 0, and then if this number, the new number you get, is divisible by 11, then yes, it is a multiple of 11, or it's divisible by 11. The whole big number is. So in this case, 0 is divisible by 11, so this whole big number is divisible by 11. And then lastly, what is your favorite number? Is it prime or composite? I don't really have a favorite number, so I'm just going to skip this problem, but you can think of your own favorite number and try to check if it's prime or composite. And that's all for today. Thank you for listening.